Happy technologies!
Hello everyone. Welcome to today's webinar on ePrep's sample prep solution, the ePrep One. I'm Oliver Deutsch, Chief Business Development Officer at HP Technologies. We're a company based in Tübingen, Germany, and we've been serving the life science industry with laboratory devices and software for 32 years now. Before I hand over to Dr. Markus Rothe, Head of our Instruments Division, I would like to address a few housekeeping issues. As you've seen in the agenda, the webinar is scheduled to take 1 hour, including the Q&A session. I encourage you to ask questions. Please type them in the chat anytime during the webinar. We'll read them out and answer them in the Q&A session. This webinar will be recorded, and we may use the recording in the future. In that case, we will make sure to remove the names and video footage of all listeners so that you won't be recognizable. Now, I'm looking forward to the webinar. I'm handing over to you, Markus.
I'm representing the distribution part of HP Technologies. So we are distributor of the ePrep One sample preparation system for Germany, Switzerland, and Austria. And I'm happy that we have today here Cassandra Rasha. She is a European application scientist from the company ePrep. She has a PhD in chemistry, and she's really an expert in chromatography and the according sample preparation. Yeah, and today she will give an overview of the ePrep. And yeah, with that, I give it over to you, Cassandra.
Thank you. Thank you for that very kind introduction, Markus. Okay, thank you everybody for joining today. I will just put up some quick slides, but the purpose of today is to give you a demo of the instrument. So I will be switching my camera over to the instrument. So just to get us started, I wanted to give you a little bit of background as to who ePrep are, as you may not be familiar with the company themselves. So we're an Australian-based company, and the team who built the business are the same team who built very well-known businesses such as SGE Analytical, for those of you who have experience in gas chromatography and perhaps use those syringes and the technology that they have developed, and ETP electron multipliers. So they've had over 60 years of experience in this industry, working with analytical chemists, and as part of that, they really identified that sample preparation techniques and the practices that we're now using have kind of lagged behind slightly compared to the analytical instrumentation in the chromatography laboratory. So if you look at where we are in terms of the sensitivity of LCMS instruments and GCMS instruments, the weak link that we see is really the sample preparation side of things. And as such, the team have developed the robotic sample preparation workstation, which will be the focus of today's presentation, but also a digital handheld syringe, and then supporting consumables around that. So we've developed some micro speed cartridges, which is really, which are micro SPE products. And then also to support the instrumentation, high performance analytical syringes. I've got a couple of points that I'd like to just introduce very early on, and that is around the reproducibility of the instrument. And also I will go into a few applications just to give you a little bit of an idea of where the instrument is used, and gives you a starting point perhaps to as to how this instrument is applied in the laboratory. So the slide I have up here is an example of the quality of the accuracy and the precision of the instrument. So this was a little challenge set to us by a customer, and they weren't interested in talking about the instrument until we'd completed this challenge. They had a member of staff who was considered an expert in sample preparation. And then they had a trainee who joined us as well. And in that process, we created 10 calibration standards, just with caffeine, nothing too complicated. But in this process, they were making up those 10 calibration standards in a 100 ml volumetric flask. We used 1 ml, we scaled it down to 1 ml so 10 calibration standards in 1.5 ml vials. So we created 1 ml of each standard. As part of that, we also developed the workflow because we weren't expecting this. So the overall time taken to achieve that was, that's recorded here, was both the development time to prepare the workflow and then to run the workflow. And you can see that obviously in being able to scale those methods as well, we were able to use a lot less solvent than the manual process. And you can also see here that in terms of our precision, we achieved 0.2% RSDs when we ran the analysis of the samples as well at the end. And I would like to highlight as well that the expert also achieved very, very good RSDs here. However, you can see that the trainee, achieved what would not be ideal precision for production of calibration standards. However, and with differences in training, you may find that this is an area, if you see high staff turnover, this is an area that many labs face as a challenge if you're always working with someone who is being trained in the particular process. So these are just a quick summary of some of the application areas that we work with the ePrep 1 sample preparation workstation. So you can see here, we've got chromatography calibration standards that's been put into environmental, but is applicable across many, many areas. Within here, we've got very common applications in the environmental sector, such as volatile organic compounds, semi-volatile organics, and a big focus area for us at the moment is PFAS in waters and soils. We've also had success with applications in cannabis analysis. So those types of methods are really going through a very common protocol, which many of you may be using in another form, whereby we are extracting from the solid cannabis leaf in this case, but we're running an extraction process with the solid cannabis leaf, and then moving the extraction solvent through a filtration process, and also adding various standards in there as well. And then that is outputted in the final HPLC vial, which can then be taken away to the instrumentation for analysis. As I mentioned, PFAS in soils is a very big area for us, and this is just an idea of how we break down some of those methods. So I won't go into this in too much depth. I will share the slides with Oliver, who will be able to communicate these with you afterwards. But I'm just conscious of time, and I wanted to give you a little bit of insight into how we approach these methods. We have everything that's all of our syringes, which is as standard PTFE, we have available as Teflon-free versions, which is obviously crucial to avoid contamination coming from the instrumentation. Through the process, we do a controlled solid liquid extraction, very similar to that cannabis method that I mentioned, but we use a unique polygonal sterobead. So this is really designed to, this is something we designed to allow us to break up the solid lumps that form in soil samples, and that is available uniquely from us. Within this method, we use a combination of automated and offline processes. So people come in with different expectations. So we find that in many instances, we can fully automate a complete workflow. There are certain aspects where we can't, and it doesn't make sense to fully automate the workflow. So in this particular case, a manual intervention is required to take the vials away for blowdown, for example, or for any other more significant intervention. So for example, we do not have on the instrument a centrifuge. If you felt that that was an integral part of your method, then we would help with development of a workflow that then allows you to take your samples away for centrifugation, and then bring it back as a second part of the method and complete the process. And this is just a quick example of the use of the ePrep 1 system for automated liquid-liquid extraction. So as I mentioned, the instrument has been used in the context of the analysis of volatile organic compounds, and this particular method follows the EPA 3511 recent method that's been recently released, and this begins to look at micro extractions, therefore allowing you to start with smaller volumes in place over, say, previous methodology, which has required, say, a litre of water sample to be introduced. For awareness, our starting volume for most samples, our largest starting volume for most samples is 50 millilitres. So that's where we can start in terms of the size of the volume of the vials that we have, and then for the most part we're looking to obviously work those samples into smaller volumes, and we can again assist with adjusting that methodology. And this is just a quick overview of that cannabis potency testing method that I indicated we've run. Okay, with that in mind, I'm going to switch my video over to the instrument. Hopefully that's all visible to you. And you can see here that we have the instrument, and here we have the robotic arm. I'm just zooming in on the main tool rack area. So as I've mentioned, we are really targeting and looking at addressing the challenges faced in sample preparation for the chromatography laboratory. With that, there are lots of challenges around the solvents that are handled and their compatibility with plastic-based products that are commonly used. So with this, we use analytical syringes, and the system really is about the automation of the analytical syringe. We do not use pipettes, and that gives us an advantage in that with analytical syringes, we can then begin to push pressures as well, which allows us the use of solid phase extraction techniques and syringe filtration techniques. So we can incorporate all of these types of methodologies onto the system. So you can see here that we've got our standard analytical syringes. We have products available that are 10 microliters, 100 microliters, 1 milliliter, and 10 milliliter. We also have on the instrument our Lewis style fitting syringes. So we have these in 10 milliliter and 2.5 milliliter. And these are really for combining with your Lewis style consumables, such as your syringe filters and we also recommend the use of Lewis style SPE cartridges, which are commonly available from a range of manufacturers. So with the syringe, you can have up to 12 tools on the deck. They're all identifiable by their RFID tag, but within that, there is also a serial number. So if you wish to have one syringe tied to a particular task, then that is possible to achieve. If you, as an example of this, we have customers who perhaps use this for very low concentration samples they might want to handle with a particular syringe, so as not to introduce contamination from high concentration samples. For example, when preparing standards, this can be quite critical. As I said, there's then possibility of 12 tools. You could have this set up as all identical tools. So this could all be 12 1 ml syringes if you wanted, or you can have quite a wide variation. As standard, we have a 80 ml needle attached to our syringes. We then also have a longer reach needle for very tall tubes, such as your Falcon tubes, for example, in order to optimize the reach into the vial. And what's critical here really is that our system is developed for use with septed vials. So in the majority of cases, we expect that you can use the system with a vial with a septor in place. Therefore, you're using a sealed container through the process. It is possible to use decapped containers, but obviously that then could present a challenge in the lab if you are using, for example, your samples of VOCs. You don't want them escaping into your lab environment. So just moving to the side here. So if we're using syringes and reusing them between samples, for example, you may be asking how we handle carryover. And with that, I just want to point out that we have a wash station at the back here. So that is used as part of the process within a workflow to rinse the syringe as needed. So you can control this completely within the workflow. And all the settings can be fully programmable. So the wash station itself can be used with up to 100% alcohol, so IPA or ethanol, methanol, but also some combination as needed with water. What I'd also like to now move on to is just begin to show you the accessories that we have. So this section of the deck is what we call our main accessories. What I don't have here, unfortunately, is there is the opportunity to introduce a bulk solvent manifold. So that can be used with a number of different fittings. So whether it's for needles, for the Lewis style fitting, or for our micro SPE, that can be used that is designed with the wash steps, conditioning steps, etc. Of solid phase extraction in mind. It could be another way of bringing in bulk solvent onto the system as well. As I said, we don't. The largest container the system takes is 50 milliliters. We also have our probe dispenser. So this again can be moved around the deck and is 5 milliliters. but it can do rapid refills. The syringe is set to the side here. And so you can do multiple cycles very quickly. So that's really ideal for addition of things like extraction solvents and diluents, where you perhaps need a slightly larger volume. So for example, it could very quickly run, add 20 milliliter to a sample just through running 4 cycles. We then have here the tools around the use of the Lewis syringes. So we have an aspiration needle. So the syringe comes along and we'll pick this up in order to aspirate and fill the syringe. And then it will dispose of, put that back down before going and collecting a relevant consumable, which it can then dispense through. What we then have here is a touch-off point, because we see a wide variety in the sizes and dimensions of the consumables that are used. So for the plastic consumables, we can see slightly variations in height, which can be critical if you are trying to program the height of your the needle depth that you want to achieve in the vial. So you may be looking to aspirate from a particular depth because you don't want to aspirate from within a solid sample, for example, or you may be looking to aspirate from a particular level if you have, say, a liquid-liquid extraction process going on. So now moving on to the main deck. From the instrument perspective, our primary objective is to provide the adapter plate. This then allows you to use the racks that you are familiar with around your lab. So this particular one may be familiar to those of you with Waters instruments, and is the auto sampler rack for water security. We also then have solutions for classic sample Bella style racks, and a whole range of other products such as those from manufacturers such as Sapelco. In terms of auto sampler racks, we have adapter plates for auto sampler racks. We have products available for Shimadzu, Agilent, Waters, as I said, Hitachi, a whole range of different instrumentation manufacturers. If we are missing a product, we're very flexible and able to develop something relatively quickly if the rack is provided to us, we can go through that design process if needed, or adaptation of existing products. What we also have specially designed for the system are products for magnetic stirring. So under here is a 60-position magnetic stirrer. We also have a 30-position product available. We have a vortex mixer under this rack here. And then we have a solid phase extraction rack. So this can be tubed up to the wash station outlet, and then the conditioning, washing solvents that are handled in bulk can be easily flushed to waste. What we also have to the side here is one for syringe filters. So this is a 2-layer rack, and you can use up to 30mm syringe filters as well. We've got a range of vials here. You can use commonly available products such as headspace vials from various manufacturers. It would just be a case of working through the process and understanding which ones are compatible, and then if you have something that isn't already in the software, then we can just get arranged to program it. So every time we talk to a customer, we come across a new type of vial that's a slightly different dimension. So it's quite common. And you can see here, these are the specially designed vials we have for liquid-liquid extraction. So in this case, this is designed for where the organic is expected to sink to the bottom. So perhaps DCM, and then you can extract it up to the top, nebulize it through the sample. And with that, we find that 2 or 3 processes achieves highly efficient and highly reproducible liquid-liquid extraction process, particularly compared to the manual process with larger bulk solvents. So that's a very brief overview of the product itself. What I'd like to do now is give you a very quick introduction to the software before coming back to the instrument and showing you a demonstration of a workflow. Okay, so hopefully you can see my screen and you can see our software. So if I just go into a new workflow, you can see here that it comes up with the ability to add a task. And these are all grouped by very common terminology within the laboratory. So you can see here for liquid handling tasks, we have common tasks such as adding a diluent, adding an internal standard, and aliquoting a sample. What I would do is I will just add a very basic workflow. And you can see here, there are a whole range of tasks there for you, as well as additional washing tasks if you have particularly sticky samples, various tasks for micro SPE, the push through SPE, filtration, and then other options such as opportunities to introduce pauses and prompts if you need to allow for, say, settling time if you're handling a solid sample, or you perhaps want to be able to take the sample away to do blowdown and then bring it back. That's also an option there. So within each task, there are a whole range of settings that are fully programmable and easy to select. So you have the opportunity to select a tool. In this case, I'm adding the probe dispenser. And then besides the volume, which I will say, besides the volume, there's then a whole range of settings that you can adjust. So there's opportunities to change aspiration rate, flow rate, dispense flow rate, according to the viscosity, to adjust for the viscosity of your solvent. In this particular case, there are purge settings in order to rinse through the probe dispenser. And then there's a range of advanced settings and mixing settings that are also available. For this tool here, we will say we've got an internal standard and we will add 100 microliters. And again, you can see here that you can control how often you are washing and where you are washing. So if you needed to wash in a stronger solution that may be sat in a vial on the deck, there's the opportunity to adjust the settings to that rather than the wash station. You also have opportunities for adjusting the priming settings. So it may be that you have very expensive internal standard and you don't want to prime anything to waste, because otherwise that's a lot of money going into the waste. But it may be that you find that you do prefer to prime to waste, in case you dilute the sample with, if you have a very critical concentration. So you may wish to avoid dilution of the sample with any trace wash solvent that may be in the needle. So really it depends on the overall method that you are running. And then there's opportunities to completely control the positioning of the aspiration needle. So it may be that you want to aspirate at a particular height in order to not collide with the magnetic stirrer bead or the solid sample, or you may wish to dispense at a particular height. Again, you may wish to not disrupt a solid sample that is sat at the bottom. I'll just choose a final tool for aliquoting our sample. And what you can also do as part of this process is with, say, the syringe for the internal standard, you can aspirate 10 say your volume was 10 microliters in this case, and you're using the 100 microliter syringe, it would be possible to aspirate 100 microliters and then do 10 dispenses if you were doing it as I have in this order, where you're just dispensing directly into clean diluent. You're not going to contaminate the samples by moving from samples to sample in this case. So that's a very efficient way of doing your internal standard addition. On the aliquot sample, the default position, default programming in the software is to take everything on a case-by-case basis. You obviously won't aspirate multiple dispensers. So within here, you can then go into your deck display and you can begin to configure your system. So this already has the tools that are available on the accessories part of the deck, but what you can begin to do is configure your rack. So I won't do this now in the interest of time, but you can see here the whole range of racks that we have available. You could also scan the racks, and this would then autocomplete if you prefer, but this is also another way of selecting the products that you want on your system. So you can see here the racks for the magnetic stirrers, and then the variety of GC and various manufacturers auto sampler racks that are available in this section here. Sorry. Okay, so with that, I will change my video over and I will stop sharing. And I will set up a workflow. So what we've also just introduced in the software is we have just launched our 21 CFR Part 11 compliant version. So for those of you operating in more regulated environments, then we do have software available for you. And as part of every starting process in the software, there are checks in place to ask you or the user to confirm that the deck is set up as appropriate to so it displays a picture of what the deck should look like, and then it begins to before it begins. So the system is just initializing. And it does this at the start of every run. So it will now go through and read the RFID tag of the tools on the back rack. And this is to check that all the tools are in place as required for the workflow. So again, if you program the workflow to require a specific serial number tool, it would begin to look for that. And then if anything was missing, it would then also check that you were happy to continue, or it would ask you to rescan, depending on if it's a missing tool, for example, it would ask you to rescan. What it's doing as well is now going through and reading the RFID tag of the plates that are in place in order to confirm that the deck is set up correctly. So it now goes through and touches off on the top of each, the first positioned vial in each rack. This is to ensure that the vials in place are of the correct height, or as expected from the workflow programming. So this is an option that you can choose when you set up your vial deck groups. And obviously there are certain racks that can hold a whole variety of different vial dimensions, particularly heights. And really the way to optimize the system is to ensure that the system knows what it's expecting so that it can take the shortest route possible, and it doesn't crash into anything that it doesn't expect to be there. So in this particular case, the workflow is set up just to do one of each process. If you had the whole deck in use, so the 60 position stirrer was completely full, then the system would also go through and use the IR scanner to check that the correct number of vials is in place. So if it expects 60 to be in place, then it would go through and count 60 vials. If one was missing, then it would ask you to check this and then rescan. So it's currently just going to pick up the probe dispenser. And it will add an extraction solvent after going through the initial wash process and the priming process. So in this particular case, it's just the multiple cycles of adding an extraction solvent. And now it will put the tool back. So the system will now pick up a syringe. And it will now pick up some of that extraction solvent and then add it to our sample vial. So the instrument is equipped with a piercer. So the piercer is designed to avoid formation to pierce the septa, but also then avoid formation of a vacuum or when the system is aspirating, or avoid overpressuring the vial when the system is dispensing. So at the moment, the system is just undergoing this magnetic stir process. Which you may be able to hear. And as I said, we've got the stirrer available in 60 position or 30 position. These are individual position stirrers that have been adapted for the ePrep. So we have these these are originally designed by Tumag, who you may be familiar with. So we're now picking up a lure tool. So the system will now move across and pick up the aspiration needle. As part of that process, it will then touch off just to check that it knows the length before going and collecting sample. In this case, we have removed the standard steps with solid phase extraction. So we're not doing the kind of conditioning and washing steps that are typically required. We're just going to, for demo purposes, show you using it. However, obviously that's fully programmable within the software. Again, the instrument is always checking the height of plastic consumables. The reason for this, as I said, is that we see a great deal of variation between the products that are available from various manufacturers. Sometimes even within the same batch of product. What we're now doing is essentially a dispense through the solid phase extraction, but this would be similar to your standard elution process. And then it puts the SB cartridge back. It would move on to the next one automatically had we, if we had multiple samples running. What you find as well with the instrument, so obviously, unlike a manual process where you may be used to handling a syringe and tapping out the air bubble by tilting the syringe somehow, obviously we're always working with the syringes vertically. The system is designed to account for the small air bubble that is produced as a result of air in the needle. and it over aspirates so that it can always accurately dispense the correct volume required. So as an example of our process for liquid extraction, you would add your solvent into the or aqueous-based sample perhaps. And then what would happen is the DCM, as an example, would drop to the bottom. With complete control of the needle positioning, we're able to set the needle to aspirate as low as possible in the liquid extraction vials, and then dispense at very rapid dispense speeds into the aqueous layer. As I said, we achieve very efficient and very reproducible extractions through this process, and the reason for that is you get nebulization of the solvent through the sample, and this achieves a maximum amount of surface area in order to allow for that partitioning process. So again, we're just going to do a syringe filtration process. So the system has gone and picked up the aspiration needle. For filling the Lua needle syringe. We'll now pick up a syringe filter, and then it will take it over to the wash station in order to fill the syringe filter volume. So at this point, it's just filling the residual volume of this syringe filter in order to ensure that you are accurately dispensing through the filter. And then this again is going into the output vial, which can then be, once it's done, can then be taken away to your HPLC or GC instrumentation. What we then have over here is a filter waste chute. So it pops off the used filter, and that can go into a disposal container. And then we have one final vortex mix of this. So that's the workflow completed. The arm will now go back into its parked position, ready for its next method. Okay, so that's it from my presentation. I open the floor up to questions, Marcus.
Okay, thank you, Cassandra. Very nice presentation. So the first question we had was, is there any cooling for the sample?
So we have we don't have anything currently. We do have a heater cooler in development, but it would be under discussion on an individual case-by-case basis at this stage. But it is something we have in development.
Yeah. So then we had the question, do you offer a kind of a starter kit with racks and adapter plates, maybe vials?
Yep, so the instrument that's purchased comes with 3 syringes as standard. It comes with the waters rack as standard and the adapter plate, and then a selection of other plates. So I think there's something for the Bellart style racks, and various tools. Everything is completely configurable from that point onwards. So the basic unit, because there's so much variation in terms of what people are doing and what people require, everything else is kind of done as an add-on, but we can really support with that, and helping develop the correct configuration for each individual customer.
Yeah. Next question is, does a sample syringe have level detection?
Liquid level detection?
Yeah.
No, that's not something we currently have in place. So all of the vials, however, as part of the workflow, should be programmed to with a volume. So if you expect that there is 10 milliliter in a vial, then the system should be told that there is expecting 10 milliliters in a vial. And as part of that, that then is built into the validation protocol as well to ensure that you've got the correct volumes coming into the system, and also you're not overfilling vials. For example, if you're saying that it's a 1.5 mil vial, you're not trying to put 3 milliliters in it as part of the total workflow process. So there is not liquid level detection, but we do have a degree of programmability in terms of the vial volumes.
Is the software and the PC included in the standard configuration? I can even answer this. So yes, it is. So we deliver the ePrep with a small laptop, and the control software is on it. Yeah.
Yeah.
And then we come directly to the next question. You already mentioned it a little bit. Is the software usable in GMP environment with clear user profiles and audit trail?
Yes, that's all in place in the 21 CFR Part 11.
So
the user accounts are also available
so we
outside of this regulated environment.
We launched the software some weeks ago, and yeah, so it's available with clear audit trail and user profiles. How many different solvents diluents can be configured simultaneously?
So
That's
yeah, with the probe dispenser, you can have 2 inlet solvents. With the bulk solvent manifolds, you can have 3 inlet ports, and then it has 1 waste port. So you could potentially have, depending on the requirements for your for the accessories, you could potentially have a couple of those on the side, but obviously it depends on what space you have. You could then have a larger vial, a larger 50 ml vial with another solvent on the side that you could fill up with that solvent. So I would say there's potential for 5 incoming ones using the accessories, but also yeah, there's potential for some of them to be held in larger vials. It really depends on how much you need in the long term. So what I would say is the instrument's really designed for typical chromatography method batch sizes. So from that, we see that lots of people want to handle 30 to 60 samples at a time, maybe 100, and really depending on the complexity of your method as well. Depends on how much space there is on the deck for the different steps that you want to do. So it's not a high throughput instrument. We are not looking to do 1,000 samples in one run. It's kind of fitting in that middle ground, which is the difference between some of these kind of multi-channel pipetting systems as well. So.
Okay, is sonication possible in a fully automated process?
So we don't have sonication, we have the vortex mixer. In terms of a similar process, obviously also the magnetic stirrer, but no, sonication is not currently an option.
Yeah. Yeah, and the last question, will you be at Analytica in Munich? Yes. We will have 2 booths, actually, one ePrep booth and one HP Technologies booth. So Cassandra will also be there, I will be there, Oliver will be there. So if you want to speak with us and want to see the machine in real, yeah, you can do that at Analytica.
Yeah, we can share the booth number later. Yeah, absolutely.
And if you have further questions, of course, just send us an email, instruments@h-net.com. So we will answer.
Right. Okay, excellent. So I see we've addressed all the questions, and it's bang on 11 o'clock, even though we started 3 minutes late, which I think is great. So maybe very quickly, Marcus, can you just summarize maybe the benefits of the ePrep 1 platform, when this is right for you, when it maybe isn't, I don't know.
I would say the ePrep is a good machine. It's an open system. It's very flexible, and the advantage, of course, of robotics, everybody knows that, is reproducibility. And I think also the ePrep is the software is very easy, so you can learn it. I had it once in demo situations that customer learns software in 4 hours, and you do not by themselves. So you do not do a training or something like this. They can very easily get into the software. And it's a flexible system. You can do many protocols. You do not need a service technician to change the protocol, and so that's good.
Okay, thanks, Marcus. Cassandra, would you like to add anything to this?
I think really I'd like to just kind of return to that idea that we're kind of sitting in the middle ground, where you might be running these methods manually because you can't justify automating them because you don't have enough samples. So we're really sitting at that smaller number of samples. You can then switch between running different methods very simply in a very straightforward way. As Marcus said, you can write your own protocol without too much effort, and that really allows for it to be used in an environment that you might not have considered for automation previously.
Okay, I think that's a very good summary. So we're at the end of this webinar. I'd just like to thank Cassandra for her contribution, for showing us the ePrep platform, and I hope everybody learned something. I definitely learned something, so hopefully that goes for the audience as well. Yeah, as Marcus wrote, questions, just ask us through the email address in the chat. Otherwise, we'll be in touch anyway and send you a quick the presentation that was shown, and we'll also send you the answers to the Q&A. And yeah, have a great rest of the day. And for those of you who'll be at Analytica, looking forward to meeting you in person. Bye-bye, everyone.
Happy technologies.